My name is McGrath Gomez, and I'll be doing calculus project number 1 for Professor Bautista. My student ID is 1252320. Without further ado, hi, my name is McGrath Gomez, and I forgot a little snippet at project number 1, so we're going to add this in. So what are limits? Well, limits of a function describes the behavior of a function at its input. So basically its x value as it gets closer and closer to a certain point without getting to that point. So the key word here is approaches, which I've underlined 3 times. So if you kind of imagine yourself walking up a hill, the limit of your altitude as you approach would be the height of the ground at that spot, even if there's a hole in it. So if you picture that if you're walking to a spot and there's a hole in it, you can't get to that hole, right? Because what's going to happen when you get to that hole? You're going to fall. Or maybe there's something that's an object that's occupying that hole, like a tree. There, you can't go in the middle of the tree, even if the point points you to the tree. It kind of points you to the direction of the tree. It leads to, but not precisely, at the destination. So you can kind of think of that tree or that hole in the ground as kind of like your asymptote. You can't physically phase into the tree. If you could, you'd be at that exact point, but you can't. So that's exactly how limits work. So limit of x approaches a, f of x is equal to L. So as the limit, the way we'd read it, as the limit of x approaches a is L, x gets close to a, the value of the f of x, so basically the function, gets closer and closer to L. In my major, electrical engineering, limits allow engineers to analyze the behaviors of circuits under various conditions, such as long periods of time. If you've taken physics, you will start realizing that all this stuff that you're doing, the calculus, they start to relate to physics more and more and more. So there's something called a steady state in RC and RL circuits. Basically, currents change over time when a switch is flipped. As time approaches infinity, what happens is that circuit settles into stability. So it kind of like grows even. So this little equation in the bottom, the limit of x approaching infinity is the voltage over time. So voltage as time goes to infinity. Thank you so much. We can resume with the rest of the project. Let's look at project number 1. So project number 1 asks us to find the limits of 3 different equations. So A, B, and C. So we'll start off with letter A. It asks us to find the following limits of, and then it gives us this. The limit, the way we'd read it is the limit of h as h approaches 0. And then it gives us a fraction. So it's the root of 15h plus 4 minus 2 over h. So the way it looks very difficult in the beginning, all we have to really remember is there's something we used in trigonometry. It was called multiply by the conjugate. If you don't know what that is, that's okay. We're going to go over it. So what it means to multiply by the conjugate. So before we get into the multiplying by conjugate, what happens if we substitute 0 into this equation? So let's put it in orange, just so we can kind of differentiate. So if we take this, and wherever there is an h, we substitute a 0. So what happens is, well, we have a 0 in the bottom. And 15 times 0, it's just going to end up equaling this weird square root of 4 minus 2 over 0, which is going to be the root, 2 minus 2 go to 0, which is a 0 over 0. What the heck does that mean? It's undefined whenever it's by 0. But that's not the answer. We can't say that it's undefined because we haven't exhausted every possible means. So we're going to come up with a new method. So it's too soon to say DNE. So does not exist. It's too soon because we haven't explored all the methods yet. So to find the answer, we're going to multiply by the conjugate. So what that means is if we take this, if we take this equation right over here, the limit of h as h equals 0, and the entire fraction, when you multiply by the conjugate, you remember you're going to keep everything in the same. So the square root remains the same. So 15h plus 4. Now, the only thing that's different, whenever you multiply by the conjugate, so whatever you do to the numerator, so if you don't know what this is called the numerator, and it's called the denominator. So whenever you multiply by the conjugate, you always have to flip this sign. So if it's a minus 2, it's going to be a plus 2. So plus 2. Now, it looks very hard because you're like, huh? What is this? Well, in algebra, we went over something that was pretty simple, if you guys remember, was that if you look at this and this, what it is called the difference of squares. So whenever you have a minus b in algebra and you square it, it's going to give us a squared minus 2ab plus b squared. So this is something that we can memorize because it's going to come up a lot. And how we can apply to this. First method, we can always do FOIL. So if we do I'm going to copy this. If we do this and we FOIL them into each other, we're going to do just the top portion because we'll leave the bottom portion away for now. If we do just the top portion, we can kind of recognize that this is A, and this is B, and this is A, and this is B. So, if we use the FOIL method, so if we do this, and then we multiply the same thing with 2. What we're going to get is, so it's going to be the root h plus 4 squared, so which is just going to be 15h plus 4, because root squared times root squared is just its number. And then we do times a positive 2, which is going to be plus 2, so just keep everything the same, so 15h plus 4 minus 2, so we're multiplying that, root 15h plus 4 minus 4, because it's a negative times a positive, so negative 2 times positive 2 is going to give us negative 4. So you'll notice the middle will cancel. Not just the middle, the 4 and the negative 4 will cancel, which will give us 15. So it always helps to remember the difference of squares, that we can identify it. So back to our original equation of that, we're going to keep everything the same. H approaches 0. So top is going to be, sorry, iPad is just being a little finicky. So 15 on top, and it's going to be h times root 15h plus 4 plus 2. Looks very, very intimidating. So the h on top will cancel out. Sorry, I forgot the h over there. H on top will cancel out, which is just going to give us this nice little equation of limit as h approaches 0, 15 over root 15h plus 4 plus 2. Now from here, what we can do is we can direct sub. So wherever you see an h, it's going to go equal 0. So 15 over 15 times 0 plus 4 plus 2. So 15 times 0 is going to give us 0, and then the bottom is going to stay the same. So plus 4 plus 2. So a 0 plus 4 is just going to give us root 4 plus 2. Now the top is going to remain the same because there's no changes to the top. So it's going to give us 15 root 4 plus 2. Which is going to be 15. And then root 4, of course, is 2. Plus 2, it's going to give us 15 over 4. And that will be our answer. So it's too soon to say do not exist. Number 2 is slightly a little bit easier. So it asks us, so the way we'd read it is limit as x approaches negative 4. What we can identify from here is that the top is a quadratic, which means 2 solutions. So on the bottom we only have one number. The top we have a polynomial. So what we can do with the top is we can split into 2. The reason why we want to do this is because if we substitute a negative 4, so same thing we did with the first one. If we substitute a negative 4 over here, and I'll put it in red, or sorry, orange, like we did before, negative 4, you'll see that we get 16 minus 8 minus 8 over 0, which is going to be undefined. So it's too soon to say that. Because we haven't explored all the methods. So going back to this, so on top we see it's a quadratic. 2 solutions, which means that we can split them. So the easiest way to split them is to factor. Now, there's a method that I had to learn. I don't really always do this method, the X method. Some people learn it. I never learned it, but the way it works is you take your number, so this one, whatever it multiplies to, it has to add to this. So -8 signs are very important, so make sure you keep your signs. So it has to multiply to 8 and add to 2. So 8, -8. If we find the multiples of 8, we're going to find 4 times 2, 8 times 2, and 8 times 1, and 2 times 2 times 2 for the multiples. Now, we can't do 2 times 2 times 2. It can't be 8 times 1. It has to be 4 times 2. So 4 times 2. And how do we know the signs? So let's set up our parentheses. So we know it's going to be 4. We know it's going to be 2. So how do we know the signs? So if the bottom number is positive, that means the bigger number on this side has to be positive. Which means that the number on the right side has to be negative. And we can always FOIL to verify. Squared minus 4, it's going to be plus 4x minus 2x minus 8. So 4x minus 2x is going to be x squared minus plus 2x minus 8. So this checks out. So this is how we know this equals our original equation. So we know it checks out. So after we factor, what we are left with is the limit x approaches -4, and on top we have x, so this and this, x plus 4, x minus 2 over x plus 4. So x plus 4, they can cancel out. So we are left with x approaches -4, x minus 2. Now from here we can just do direct substitution. So -4, wherever there's an x, we're going to plug in a -4. -4 minus 2, it's going to give us -6, and there we go. We have our solution. It's going to be -6. Now, moving on to problem C. So C, there's 2 ways to do it, and as before, if we plug in a 0, sine of 0 is equal to 0. If we plug in a 0, so the way we'd read it is limit as y approaches 0 is going to be sine of 19y over 4y. So if you know the sine of 0 is equal to 0, if you don't know what the sine value is, basically just the y value. And because sine is equal to y. So if we know it's 0 and we plug this in, write in orange, 19 times 0 over 4 times 0, we get the same thing. So it's a 0 on the bottom and 0 on top, because 19 times 0 is just 0. But it's too soon to say that. So we got to approach it a different way. So there is a theory we have to learn in calculus. It's a very different theorem. Now, what that theorem says is that the limit, sorry, I'm right over here, the limit as y approaches 0 sine of y over y is just equal to 1. So if we remember this theorem, we need to memorize this theorem. So if you remember it, we can kind of think, what can we do to apply this to over here? Well, there's a couple things we can do. So copy this problem down. There's a couple things we can do. The way I'm going to say it is, what we need to do is make y equal to y, which means that we need to multiply this number by a fancy one. Thank you for Professor Bautista for showing us how to do the fancy ones. I loved it in the trig class, sorry, not trig class, the pre-calculus class, and I love it in this class too. So it's going to be basically what we need to do is multiply both numbers by 19 over 19. But we're going to write it like 19 over 1 times 19 over 1. Now, if you guys remember, we could always change the multiples. So like 3 times 5 is equal to 15. And 5 times 3 is equal to 15. So this is a rule that multiplications have. It does not matter which side the 5's in. It will always equal 15. So we can kind of do the same thing. So we're going to fancy 1 and split the equation. So the way I do it is limit as y approaches 0. We're going to split it. So the 19y, we're going to pull down. So 19y, the sine of 19y, over 19, because 19's right over here. So it's 1 times 1 over 19. It's going to be 19y. We're going to split this 4 into here, which is going to be just 19 over 4. Now we can apply the theorem. Do you guys see where the theorem can be applied? It's just sine of 19y over 19y, which is just going to be 1 times 19 over 4. As y approaches 0, which is going to give us just 19 over 4, which is just 19 over 4. Now, there is another way to do this. There's a gentleman back in the good old times. His name is, I think it's called El Hospital. I don't know how to really pronounce his name. La Hospital. He basically has a rule, which we will learn later on. So anytime y is equal to 0 and it results in 0 over 0, it's going to be called an intermediate form. The way he kind of figured it out is if you take infinity on top and it's divided by infinity, it's just going to be infinity. And 0 over 0 is kind of a similar concept. So the rule that he created is that the limit of a quotient of functions in an intermediate form is equal to the limit of the quotient of their derivatives. Now, that's a fancy word which we will learn in probably the chapters coming up. What it means is you write down the equation. So if you bring down this equation, what we can do is we can find the derivatives of the sine of y. So we keep everything the same. So y approaches 0. Find out the derivatives. So d over d of y. So we find out the derivative of the sine of y. And find out the derivatives of of 4y. So the derivative of sine 19y is pretty simple. It's just 19 times cosine of 19y. So you can see that there is a pattern. And the derivative of 4y is equal to 4. So the way it works is if there's a limit, y approaches 0 for y, all you'd have to do, so if this was, is just 4. And kind of the same thing for this. Since what's going to change is the sine and the cosine and the multiplication. So you pull it up. So if we plug that in, if we find out the derivative and we plug the derivative in, so the limit y approaches 0, 19 cosine times 19y over 4, and then we can plug in and just direct substitute. So wherever there's a y, we're going to make it 0. So the cosine of 0 times 19 over 4. So the cosine of 0 is equal to 1. So 19 times 1 over 4, which is going to give us 19 over 4. There we go. Easy peasy. So this equals the same as our original answer. So there's 2 ways that we can do it. Thank you so much for tuning in. I want to give thanks to a couple different people. Of course, Professor Bao for showing us the fancy ones and always keeping us informed and how to do our problems. Brian McLogan, I watch his videos often, and sometimes when I get stuck, his videos make sense. Organic Chemistry Tutor, I use 2 of his videos to kind of reference